Okay, and we're back. We're live. Should be a pretty quick lesson, but again, just want to go over some stuff on ionic solids. That will be, again, the homework that you can work on in class tomorrow. In addition to worksheet 2, I want to first go over the ionic, what's going to be on the ionic solids. That's worksheet 3 that I sent to you. You'll notice I sent you 2 things, worksheet 2 and worksheet 3, and again, both of those I'll have due on Friday. Obviously, for those that are gone for state wrestling, just bring them in when you come back on Monday, okay? So you'll have time to work on both of those tomorrow. I want to go over the rules first for worksheet 3, and actually while I'm at it, I know I didn't share this electronically yet, but I will, just in case everyone wanted a paper copy. I'm just going to hand you guys a paper copy of this too. These are the single element, some of the single element ions, and also polyatomic ions. There you go. And depending on the questions that they give you, you may also, in addition to this, want your periodic table. We did go over charges from the periodic table. Always reference your periodic table in addition for single elements. Remember that you can find the charges by looking at the sample element, seeing where it says oxidation state, and then for the element that you're looking at, going to that same area for your element. It's in the lower right-hand corner of your element. It should be a number. If it's just a plain number, that means it's a positive charge. But if you see a negative sign behind it, it's obviously a negative sign. Or sometimes you may see a plus or minus. General rule of thumb is to go by the charges that we did for each respective column. And then for the ones that are in the middle that we didn't assign an actual charge to, you'll have to take a look at the element and then make a decision based on your negative ion. Okay. Okay, so ionic compounds, worksheet 3. First of all, so actually if you're not there, please pull up worksheet 3, ionic compounds. I want to start with this one first. The other one, I'll let you work at your own pace. I'll be happy to go over that a little bit more tomorrow. If you have any particular questions, feel free to ask me tomorrow, and I'll also go over it tomorrow. For those that are going to be gone tomorrow, basically with worksheet 2, you're just telling me on like which planets is it going to be a liquid, solid, or a gas based on its melting point and boiling point. So you're having to compare the temperatures. You're having to compare the temperature of that planet with the melting and boiling point temperatures of that substance. Now, in terms of ionic compounds, we've already got our basic properties that we know about. We know that ionic compounds have 2 types of charges. In order to be an ionic compound, what are those 2 charges? What are the 2 possible charges that you can have for an ion? Positive and negative, yep. So ions are positively charged and negatively charged. What side of the table do we find the positively charged ions?
Left side.
Left side. So then the negative ions come from the right side, right. In your periodic table, you should have that division there. As a friendly reminder, it's kind of like this stair ladder here. basically starting with column 5A, -3, -2, -1, 0, and then from column 3A going to the left, they're all positively charged, okay? So the basic structural unit is again that you have one ion surrounded by 6 oppositely charged ions. That's its structure. That's what we saw in the crystal demo that you have the computer activity. There's one ion that's surrounded by 6 oppositely charged ions. Okay, and then the ions, as we should have down as a definition already, are these charged atoms. And how is it that they gain or lose it? How is it that they get their charges? What happened to them that they either that they get a positive or negative charge?
They use or gain.
Lose or gain what?
Negative.
What's that? Electrons, yep. So if you're a negatively charged ion, that means you gained electrons. If you're positively charged, that means you lost electrons. Okay. And with those ionic compounds in the shocking revelation activity, say like salt, or I'm trying to think of some of the other ones that you had, salt or potassium carbonate. What did salt do with our conductivity meter and with our light bulb apparatus? What did salt do? Like plain table salt. If you put salt in water, what happens to that light bulb? Yep, conducts electricity because it turns into ions. Yep. So the properties of ionic compounds: in the liquid state, they'll conduct electricity. In the solid state, they will not. They're a little bit too close together. Remember, we had the example of the solid that solid salt that you tried to conduct, that you tried to test. It wouldn't do anything as a solid, but when I melted it, then it would. And then when we put it in water as a solution, it also conducted electricity. Okay, so it spread those ions apart. Okay. So that's kind of the basic thing on those first two definitional type of things. Now, in terms of writing formulas for them, all we're doing is we're matching up charges so that the charges balance out to be 0. We want the positive charges and the negative charges to sum up to 0. Okay? So, for example, to start with, we have the Na2O. Oops, that's going bad. Ooh, try to do that right-handed, and I'm not a natural right-handed shooting guy. So, rebound score. So sodium oxide. So in this one, there are 2 sodiums and 1 oxygen. Okay. Now, from our periodic table, sodium is in column 1. It has a charge of a positive 1. That is column 1A. Oxygen's over here in column 6A. That's the one that we gave the overall charge of -2 to. Okay? So when they put it together, we need 2 sodiums to go with 1 oxygen, so that way the charges end up balancing out with one another. 2 positive 1 charges with 1 negative 2 charge. So overall then, if I've got a positive, a negative, and a positive, what's the overall charge of the compound? 0. So 2 positive 1s plus a negative 2, the overall charge is 0. And that's what we want. We want to balance out those charges so that the overall charge of the compound is 0. Okay? Now, this particular worksheet, we're just going to only be working with single element ions. Okay? With single element ions, you won't have to worry about the polyatomic ones yet. I'll have another lesson later about polyatomic ions. Okay, so that's how you put the formula together, is you're just figuring out first what are the charges of each respective element, and then figuring how many of each one do I need to have in order to make the charge 0. Now, when I'm done writing the formula, erase the charges. You do not want the actual charges in as part of the formula. That's to help you figure the formula, okay? Now, in terms of naming, when you name it, you name the positive element just its regular name, so sodium. And then the oxygen is your other element. What you do is you drop the suffix. You drop the suffix at the vowel, and then you add IDE. So sodium oxide. Now, I know I didn't get a ton of time to work on that yet. If you want to try it out tonight, that's fine. I will do more lesson tomorrow, or I will tape it. And for those that are gone, I'll happily send you the video for it. Okay? So this first one is known as sodium oxide. And that's all for today.